So here are the expanded group of slides and videos where we're going to go into some math to help explain better net present value, and also even a little bit more on internal rate of return payback period and opportunity cost. So let's talk about present value. And then this is going to be a good lead-in or a good segue to net present value. And these are the most important financial concepts for PMI, for project selection. So we want to get some introduction to what these mean. So present value is a synonym for discounted cash flows or the diminishing value of money. So management does care how much money we're estimating we're going to bring in, but they also want a good estimate of how soon we're going to bring it in, because the farther out in the future we bring in a cash flow, the more it gets discounted or the more it diminishes in value. So you might ask, well, how much is it going to diminish? How do we know how fast the value is going to be discounted or diminished? So hence our equation at the top of the slide. So just reading this says the present value, what it's worth today in today's dollars, is equal to the future value when we get that cash flow divided by 1 plus the interest rate taken to the nth power, where n is the number of years in the future that we think we're going to get that cash flow. So the interest rate is some interest rate that the financial analysts, that senior management are expecting, a minimum interest rate that they expect all projects should be able to return. They know there's other things that could go do, there's other projects, there's other investments, and they think at minimum they could get 15% back on these other things. So our project should at minimum return 15%. So that's the company's interest rate, the financial analyst's interest rate. So with that in mind, what is this $100,000 1 year out in the future that we might get it? What is it worth in today's dollars? So we just plug in the values into our equation. So there's our equation, and we plug in the values in the table right above. So we're solving for present value. The future value after 1 year in operations is $100,000. The interest rate is 15%. So we're dividing $100,000 by 1.15, that's 1 plus the interest rate, and we're taking it to the first power. So this is 1 year out in the future, we're getting this cash flow. So we plugged in those numbers, and now we're solving for it. So that's the same as $100,000 divided by 1.15. And you do that simple division, and that's 86,957. So this is saying that $100,000 1 year out in the future, where we're expecting in our company a 15% interest return on anything we invest in, that $100,000 in today's dollars is really just worth 86,957. Another way to look at it is if you had $86,957, you could put it into some investment that you knew was going to return 15%. Then after 1 year, it's going to grow to $100,000. Okay, something more to add about this interest rate that's used in this formula for present value. There is no standard for what that interest rate should be. So for this company here in this example, that interest rate was 15%. Well, they're doing pretty well. Maybe this is a company like Google or Apple, and they've got a lot of appetizing opportunities that they can go after, and they're expecting at a minimum a 15% return. But perhaps we could be a company that's in a much tighter marketplace, a commodity-driven marketplace where the margins, the profit percentages are much less, and their interest rate that they're expecting, their minimum interest rate could be much lower, maybe even 5%, 6%. So it just depends. It depends on our company. It depends on the marketplace. It depends on how tightly regulated the marketplace is and such. So there are many variables that are going to impact what that interest rate should be. Okay, so now we want to use what we know about present value to get an understanding of net present value. So what we're showing you here is the projected or estimated returns for a project in operations from year 1 through year 5. And so these are future value cash flows that we're estimating, again, out in operations. So in year 1, we're estimating we'll bring in $20,000. In year 2, at the end of year 2, we'll bring in $30,000. Year 3, $30,000. Year 4, $40,000. And year 5, $40,000. Those are the estimated future value cash flows in those years in operations. And also, we put in what we think the project's going to cost, and that's year 0. So however long the project life cycle is going to take to do this project, that is year 0. Whether it's 6 months, 1 year, or longer, that's year 0. So that's a negative number. So it's a cost, so that's in parentheses. So those are, the middle column is our future value cash flows. And now for each of those future value cash flows, we're computing the present value. So we just pumped negative $100,000 through our equation up above. So we've got negative 100,000 divided by 1.15 to the 0th. So 1.15 to the 0th is 1. Anything to the 0 power is 1. So we've got negative 100,000 divided by 1. So the present value in year 0 is also negative 100,000. We pump, for year 1, we pump 20,000 through the equation. 20,000 divided by 1.15 to the first is 17,391. For year 2, $30,000 divided by 1.15 to the second, or squared, is 22,684. So just one more. For year 3, the $30,000 divided by 1.15 cubed to the third is 19,725. So the right-hand column is the present value calculations of the future value cash flows. And we just sum all that up. We sum up all the positive values from year 1 through year 5. We get that number and we subtract year 0. So we subtract the cost, negative $100,000, and we get a sum or a net of $2,257. So that is net present value. That is the net. That is the sum of all the present value calculations of year 1 through year 5, subtracting the costs. So I put you through some pain and agony to try to understand some details and understand net present value in more depth. You probably, again, on the test, you're not going to have to use the equation for present value, and you're probably not going to have to compute the present values for a project in a number of years in the life cycle. But I think that going to this depth does really make it more clear and bring it to a light what net present value is. And again, for PMI, this is probably the most important of the different benefit measurement methods in project selection. So really all you need to know about net present value is that bigger is better, and that costs have already been factored into the project in net present value. We subtracted year 0, so we factored cost into net present value. Okay, 2 more financial concepts to go over, and they are payback period and opportunity cost. You might see those terms on today's exam still in 2017. Probably not going to have to do any math with it again. But payback period, now smaller is better. And management not only cares how much money we're going to bring in over time in operations, they want to know how quickly we're going to bring that in and how quickly we're going to recover or recoup our upfront costs. And so for here on this slide, for this project, the costs to do the project are $75,000. And then we're seeing on the next row down, we're seeing the estimated revenues in operations for year 1, year 2, year 3, and year 4. So what is the payback period here? And you would say, oh, somewhere in year 3, we're recovering that $75,000. So is it 2.3, 2.4 or something? No. We round up to whole years for payback period. So the payback period for this case is 3. And last is opportunity cost. So you might see this term on the exam still today too in 2017. So I think for me this is kind of a funny term. Opportunity cost doesn't really tell me what's going on here. So the opportunity cost of a project is the value of the project that we passed up. So the next best choice project that we didn't take is the opportunity cost. And we're hoping we didn't pass up a really good appetizing opportunity. So a lot of people say that smaller is better. We're hoping that this opportunity cost wasn't something really big. So suppose we've got these three projects here. Project A, its net present value is 1.3 million. B, the net present value is 1.1 million. And C has a net present value of 1.5 million. So just based on that, which project, you can only pick one of these. So which project would you pick? And of course, we're going to pick C. It has the highest net present value. So if we pick C, what's the what's the opportunity cost of picking C? Well, you don't add up both of net present values of A and B and come up with 2.4 million. It's the next best choice, or the value of A. So $1.3 million is the opportunity cost of picking C.